Hi, we are Group 45. We are making this video to introduce our work to developing an AI player for the Azure game. In this video, we will discuss and analyze the design idea of our agent and how it works. We will also talk about the challenge we faced during the development, and we will give some possible future improvement to our product. At the end of the video, we will demonstrate a match between our final approach agent and our baseline agent. First, let me briefly introduce the Azure game. The Azure game is a competitive board game for multiplayers. It has a complex scene compared with the Pac-Man. The player with the highest score at the end of the game will be the winner. To be noticed that each game starts with a random state, which means every game could be different, so there is no fixed winning strategy. In this project, we only consider 1 versus 1 situation. Our final solution is using Q-learning, which is a model-free reinforcement learning algorithm. Our agent works like this. When our agent's turn to move, we first calculate the reward for each possible action. Here, we manually define the reward rather than use the end-of-round scoring method. After that, the Q value for the state action pair will be updated by the reward and stored in the Q table. This process will be repeated over 100 times to find the most optimal action with the highest Q value. After we go into a new state, we will repeat the above steps for the next turn. The key points of Q-learning is we manually define the states and actions where it is the abstraction of original state. In other words, we ignore some meaningless or irrelevant properties of game state to reduce the processing time and avoid repetition. Also, the Q-learning will make sure the reward is transmitted to every previous step, which converges to the reward step, and this is how the algorithm learns from the actions. These key points are the reason why we choose Q-learning, and how it improves the performance. Our agent ranked 11 in the practice tournament. We also faced several challenges during the development. First is the technical challenges. None of us has played Azure before, so understanding the game rules and connecting them with the code is a big challenge. Then is the features extraction. We were struggling in determining what property should be regarded as a feature. Azure has a complex scene. It requires a lot of features to fully represent the current state correctly, but too many features will reduce the response speed significantly. We still cannot say the feature used in the final approach is the most suitable one. Nevertheless, reward definition is also a hard problem, as Azure only gives score at the end of the round, but the previous state and action may cause positive or negative results. To separate them, we need a reasonable reward function for each action that player has taken. Here, we also have some ideas about future improvement. First is game theory. As we mentioned, Azure is a competitive game, but currently we only consider our situation and ignore opponents. In other words, our goal is to achieve the highest score rather than achieve a higher score than opponent. However, sometimes countering the opponent action might have a better effect. Based on that, the average score might reduce, but the win rate can be much higher. We also want to reduce the response time. A possible way is using an asynchronous method, which is only updated the Q values for the current state in each iteration. With this method, the response time can be reduced to an acceptable range. Here is a demo of game between two of our agents. The final approach Q-learning agent and our baseline heuristic search agent. The main strategy of our Q-learning agent is to achieve higher score as much as possible, and we manually define the reward function. If the action completes a pattern line, the reward will be the score. Otherwise, the reward will be discounted according to the number of tiles to the pattern line, divided by the pattern line size. You can see that at the start of the game, the agent picks 3 red tiles into the third line, and it can fill the pattern line exactly without any floor penalization, so it will achieve highest Q value and we pick this action. In the next turn, the agent picks 2 white tiles into the second line. The reason is the same. This strategy was used in every step. In this situation, the best action is to pick 3 blue tiles from the center, so the opponent has no choice but to take the floor penalization. But our agent still picked the white tile to achieve a higher score and let the opponent take 3 blue tiles in the next turn. So this is the situation when to think about counter opponent to achieve a higher win rate. The final score is very close, which is 51 to 48, and the Q-learning agent win the game. During our experiment, the average win rate for Q-learning against heuristic search is 55% and 86% against the naive player. Thank you for watching this video.